The smoothing operation allows to improve the results achieved with the equalization filter, applying a fractional octave band smoothing to the transfer function. The smoothing operation allows to avoid the compensation of sharp notches in the magnitude-frequency responses of speaker and room, so a more complex and robust equalizer is provided. Several parameters can be used in order to perform the complex smoothing procedure. In order to provide an insight into the smoothing procedure, only the data about the impulse response, the cutted and the smoothed impulse response will be displayed. First of all, we are going to define the smoothing coefficient for the whole frequency band in the magnitude transfer function. The effect of the smoothing procedure is clearly visible observing the yellow line representing the smoothing transfer function. The same operation can be also applied in the phase domain. Another important feature provided by the tool is the possibility of applying different smoothing levels for different frequency regions. In this example, we are going to use two different kinds of smoothing for two different frequency regions of the magnitude transfer function. The number of bands in which to operate can be chosen arbitrarily by the user. Finally, in order to provide the functioning of the equalization tool, an octave band smoothing of 1/6 is applied for the frequency region from 200 Hz to 16 kHz. Differently, no smoothing is applied in the phase. Various target curves can be employed in the equalization procedure. In greater detail, it is possible to choose between three different target curves: flat, automatic, and defined by the user. In order to provide an insight into the target functionality, only the information about the smoothed impulse response and the target function are reported in this graph. On this basis, it's important to underline that flat curve does not represent the optimal, but is a good starting point for a subsequent improvement. Differently from flat, the automatic target follows the behavior of the room frequency response. The user can also modify the target function using different Bell parametric equalizer. In this example, we are going to introduce two of them. Finally, in order to provide the functioning of the equalization tool, a flat target curve has been considered. The core of the equalization procedure is the auto-EQ operation. Taking in consideration the previously mentioned parameters, an equalizer is designed on the basis of the selected correction window and the adaptive filtering structure. Taking into consideration the filtering structure, the user can choose among three different kinds of filter: IIR, FIR, and mixed FIR and IIR structure. Then, on the basis of the selected structure, it is possible to select various kinds of equalization: the magnitude, the phase, and the magnitude and phase. In order to provide an insight into the automatic equalization procedure functionality, only the information about the smoothed impulse response, the target, the equalizer transfer function, and the equalized impulse response function are reported in the graph. Different parameters control the generation process. One of the most important parameters is the frequency bandwidth, defined by the minimum and the maximum frequency value. The main advantages derived from the use of IR are the possibility of achieving a good frequency resolution of the magnitude response at middle and high frequency, and the possibility of introducing a phase correction. On the other side, the use of FIR is not very effective, especially at low frequency. This can be observed analyzing the red line reported in the magnitude graph that describes the equalizer transfer function. For this reason, it is important to select the right bandwidth, especially in the low frequency range. To cope with this problem, the out range option can be used.